Okay, this is lesson 14, and this covers section 3.2 in the book. And in this section, we're looking at dividing polynomials, where we have, and it just says in long division, we have a divisor and a dividend, a quotient, and we also have whatever's left over, we have a remainder. So if we have a problem such as 2x to the 5th minus 7x to the 4th minus 13, and we're dividing that by x squared minus 6x plus 8. We want to go ahead and use division, long division for that. So we're going to put our divisor, x squared minus 6x plus 8 in here. And for each place value for x, we have to have a spot. So here we have x to the 5th, we need a place for x to the 4th, and on down. X to the 3rd, x squared, x, and our constant. So we have a 2x to the 5th, right? And then we have a minus 7x to the 4th, but we don't have an x cubed. So we have to make a place for that. So we're going to put 0, x cubed. We don't have an x squared either. So we're going to put plus 0, x squared. And we don't have a place for x either. So we got to put plus 0x minus 13. And because we're working with a trinomial, we can't use synthetic division. We have to use long division. So because our divisor is 1, 2, 3 places, we have to start 1, 2, 3 places for our quotient. And we're going to ask ourselves, what times x squared will give me 2x to the 5th? And so, well, we got 2, right? 2 times x, that'll be 2. X cubed, right? Because 2x cubed plus times x squared gives me 2x to the 5th. So I'm going to write that in there, 2x to the 5th. But I have to keep going, and I got to multiply 2x cubed times a negative 6x. So 2 times 6, that'll be a minus 12, x to the 4th, and 2x cubed times 8, that'll be a plus 16. And just like with working with numbers, the second row we have to subtract, here we have to change the signs of everything in that second row. So now we've got a positive 2x to the 5th and negative 2x to the 5th. These cancel, that's what we want. Here we have a negative 7x to the 4th and a plus 12x to the 4th. So that'll give us 5x to the 4th. And here we got a minus 16x cubed. So we bring that down. And because our divisor is 3 places, we have to bring the 0 down. So that would be plus 0x squared. So now we want to ask ourselves, what times x squared will give me 5x to the 4th? And we know that would be plus 5x squared times x will give me 5x to the 4th. 5x squared times a negative 6, that will be a minus 30 x cubed. 5x squared times 8, that will be a plus 40 x squared. And again, we have to change the signs for our second row. So we're going to have 5x to the 4th and a minus 5x to the 4th. They cancel. we've got positive 30, negative 16x cubed, so that'll be a positive 14x cubed. And then we're going to bring down that minus 40x squared. So now, again, we need to bring down the plus 0x. And so we need to ask ourselves, what times x squared will give me 14x cubed? That's going to be a plus 14x. So we got 14 times x squared, that'll be 14x cubed. 14 times a negative 6, that'll be a minus 84 x squared, and then 14x times 8, that'll be a plus 112 x. Again, we change the signs, minus, plus, minus again, and we're going to get a 14x cubes cancel, 40 and negative 40 and positive 84, that'll be a 44x squared minus 112x, and we're going to bring that minus 13 down. So now we have to use 44 this time, right? Now if this was a negative here, we'd have to put a negative up here, but because all of these were positive, these are all pluses. So we're going to put 44 times x squared is 44x squared. And 44 times 6 will be 264 minus 264x. And then 44 times 8, that'll be plus 352. Okay, so we're going to change the signs. That'll make that a plus. The 352, that'll be a minus. And so we get, for an answer, we get the 44x squares cancel. We get 4 minus 2, that's going to be 2x. 6 minus 2, that's 5. 152x. And then here, we're actually going to be adding negatives, right? So we're going to get a 5, 6, a minus 365. And so this will be our remainder. And this top part, this will be our quotient. Okay, well, fortunately, we don't always have to do this long division. If we're working with just two terms up here, a binomial as a divisor, then we can use synthetic division. And let's take